This is Chapter 8 of the making of Moons of Darsalon, the video game that laughs at you when you fail. In the previous chapter, I mentioned that this episode could be about the NPC AI, liquid physics, optimizations. I'm afraid I won't be able to talk about those things for now, as they are complicated to explain and require extra work. However, we are going to discuss another feature that makes Moons of Darsalon quite unusual for a video game. It's an aesthetic aspect that not everyone has noticed while playing, but I consider it quite special, and it certainly adds a touch of charm. The grass? Well, yes, many games have grass, but not like in Moons of Darsalon. Darsalonian grass can be destroyed, and most importantly, it can grow back. Some games generate a little puff of dust under your feet when you jump. I seem to recall this, though I can't remember any specific games that do it. Moons of Darsalon does something similar with grass. It kills a blade of grass, and these die with a small explosion of leaves that fly out. This gives more credibility, we could say, to the environment. On the other hand, if we
creates chaotic results.
Yes, but in the case of grass, it doesn't matter. We're talking about a bunch of green pixels with a generally defined shape. Yes, but if some of its scaling steps make the pixels a bit random, it's not noticeable. Grass is supposed to be somewhat random too.
But doesn't this create pixels of different sizes?
No, because the rendering system of Moons of Darsalon doesn't allow it when the level started. But in the end, I decided I preferred to place the trees manually and leave only the grass in automatic mode. Well, not 100% manually, because that would be a pain. So, I modified the ground filler script to work in editor mode, allowing me to place objects on the ground, and by pressing Shift, Alt, or Control, I can plant a random tree, delete one, or modify the sprite of an existing tree. Now, the Deco Manager has an array of bytes, and another of U-shorts. The bytes can range from 0 to 255 and represent the type of object. Yes, although I am only using one type of object per Deco Manager in the end, the system allows for multiple types of objects. This type is actually the index of the store. What is a store? A store is what everyone else calls an object pool. Yes, you know what I'm talking about. When, to optimize, you don't destroy objects but reuse them, you create an object pool. And why do I call them stores? Because when I implemented my object pools, I didn't know they were called that, so I invented this terminology. Stores are the object pools, and the poolable objects are items. Back to the Deco Manager. It has two arrays, one of bytes, which is the index of the store, and the other is an array of U-shorts, which is the index of the poolable object, the item, within the store. A U-short can have a maximum value of 65535, although the grass pieces store only has 2000, which is more or less enough for the levels in Moons of Darsalon. These two arrays have the same number of elements corresponding to the map's dimensions in pixels, divided by a set width and height. In the case of the Deco Manager for grass, it is 3 pixels wide and 9 pixels high. Why 3 pixels wide? Because this way, pieces of grass can be placed very close together. And why 9 pixels high? Because it's unusual for 2 ground levels to be closer than 9 pixels. This generates a grid for each level with 3 by 9 cells in which only one piece of grass can exist. The exact coordinates are independent. Within the grid, the grass can be more to the left or right, depending on where the ground filler's raycast landed, or higher or lower, depending on the ground's height. When a ground filler wants to know if it can plant a piece of grass, using the exact coordinates from the raycast, it can easily calculate the index of the Deco Manager's arrays that corresponds to the grid we're in. This way, the first value is obtained from the first array, which indicates the store. If there's nothing, it has a value of 255. But if it has any other number, we know there's something in that cell. So the ground filler doesn't plant grass. Instead, it jumps to a new position for the next check. This is a few pixels to the side and a few more pixels up. It then fires a new raycast and repeats the check to see if there is grass in this new cell. If there is nothing, it instantiates a piece of grass and continues in the same direction. What happens if it encounters a wall? The ground filler performs a new raycast, but this time upwards, searching for the surface, and continues planting grass there. There are situations where ground fillers get stuck in a dumb loop, which is why each ground filler has a limited number of iterations. After these iterations, it gets reinstantiated somewhere else randomly. There are several ground fillers always traversing the level. Some are instantiated near the player. randomly but always close, so that not too much time passes from when you create new terrain until grass grows, while others are instantiated far from the player. The ground fillers don't all operate at the same time. Their executions are managed by a specific manager, similar to the expensive task manager I mentioned in the chapter on terrain creation. A single ground filler isn't a problem, but having many running at once is, so I make sure that only a few updates are executed per frame. Talking about the color, I've spent a lot of time choosing the color of the grass. I wanted it to match the colors of each level. Additionally, the grass reads the color of the ground it grows on. This is easy because, as I explained in earlier chapters, the ground is a large texture that is always positioned at coordinates 0, 0. So the grass coordinates on the map match the pixel coordinates on the texture. Once we have the ground color, the grass is tinted with that color at a small percentage. This allows it to maintain a general color, while some patches of grass adapt to the terrain if the color was very intense at those coordinates. This creates variety, but also visual coherence. Now, what problems did I encounter with this grass system? Normally, when you destroy terrain with the laser, you also destroy the grass on top, because the explosion, like the ground filler, checks if there was grass there to destroy it. But sometimes this doesn't happen because the algorithm for destroying terrain is complex and has to ensure there isn't very thin terrain or loose pixels that could hinder gameplay. So some pieces of grass might end up floating in the air. I solved this by storing the pixel index of the ground texture where this grass was created. Every so often, I check if this pixel is still solid, and if it isn't, I destroy the piece of grass. And there's another problem. Earlier, I mentioned that grass also consumes CPU, but how could it if once fully grown, it's an inert sprite? Well, the problem is that there can be many grass pieces instantiated, up to 2,000, and this causes culling issues. What is culling? It's the process of determining which objects should be rendered and which don't need to be, because they are out of the camera's view or for other reasons. For this, Unity's camera checks all active sprites and performs a series of checks to determine which ones to add to the render list. I honestly don't understand why this process caused so many spikes in the profiler, but it did, and in an inconsistent way. What was my solution? My own culling system. That's right, if a game object is deactivated, the camera ignores it during its culling process. So, the idea is to reduce the number of objects that the camera will test before it does so. And you might think, wouldn't we be doing exactly the same thing the camera does to determine if an object should not be rendered? And wouldn't that consume the same amount of CPU? In theory, yes, but in practice, no. Why? I have no fucking idea, but that's how it is. I do know why my culling is super efficient. But I seem to remember that before optimizing it, when I was just comparing the coordinates of the grass with the camera's rectangle, it already prevented those monstrous spikes that were being generated. However, there was still a non-negligible constant increase in the time it took to process each frame. And how did I optimize it? By doing two things, running a few checks per frame. It's not necessary to do all the checks every frame if, instead of comparing with the camera's field of vision, you add a margin. This way, only if you move very quickly will you encounter grass that wasn't there and suddenly appears before your eyes. Considering the maximum speed you can reach with the jetpack, you adjust the margin by eye. And that's it. What other optimization method did I use for culling? I did it on a separate thread. Threads are CPU processing threads. Unity, by default, is single-threaded. Everything happens sequentially on the same thread. But you can create parallel processing threads so that the CPU literally works on another task simultaneously. Well, this is possible now, but when I implemented my own threads, it wasn't. You could only create threads using Microsoft's API under .NET. Maybe one day I'll talk about how I made my ultra-optimized thread implementation, since Unity's, as I understand it, is a double-edged sword. Yes, you can perform costly calculations in parallel, offloading work from the main thread, but every time you create a thread, it generates garbage. And what is garbage? Oh God, I'm getting into too many topics at once. Let's just say that my culling works in parallel and turns off the grass pieces, and also the roots and trees that are off camera, so Unity's culling doesn't get overwhelmed. And this is the end of episode 8 of how Moons of Darsalon was made. I hope it wasn't too intense. I thought it wouldn't be as complex as the upcoming episodes on AI and liquid physics, but in the end, explaining everything about the grass turned out to be much longer than I expected. So, I don't dare to predict what the next video will be about. You can leave your suggestions in the comments, and remember to subscribe if you don't want to miss it.